Hey, Vlad here, DependencyGraph.com. Welcome to another video. In the previous video that ended up way too long, so I ended up splitting into two. So this is the second part. We talked about top-level definitions and top-level exports. Some parts are still left. We need to talk about using exports in a local scope, the way they were actually intended to be used and not the way I abuse them. In any case, I'm going to shut up and let's get right to it. So this is pretty much where we left off. This was our gigantic Zio application. And I want to focus on one tiny part in there. So usually inside of core, I have the so-called boundary traits. These are the boundaries to the core of my application. Usually people call them services or business logic or use case or something like this. So I'm going to go into boundary and I'm going to close everything else. Okay, so it's just a trait, and over here we're going to have the implementation, which uses the anonymous class and anonymous class inference, which is kind of crazy and looks very creepy, but it works. Okay, so it wants a gateway to work, right? And a gateway is simply a trait which lives right next to it, right? So all of this stuff is in core. If I jump into Entity Gateway, they're in core, right? Both boundary and the Entity Gateway, they are in core, and it just describes like all of the stuff that that my boundary is going to be able to do with something like a persistence layer. Now, what we're going to do today is we're going to discuss what is going to happen if you're going to actually need multiple gateways. And by the way, usually people call those gateways repositories. I don't like to use the repository keyword because it exposes the fact that we're using some sort of storage. And if you were to send it to some other microservice, for example, usually people would call this thing client all of a sudden. I actually have no idea why, because it's it's the same TCP IP request. It's the same kind of level of abstraction, but somehow people call these things repositories and these things clients. I always used to just call them entity gateways, and now I'm actually evolving them. Now I'm actually having multiple of them, and I'm putting a facade on top of them, and exports are helping me to do this. So what we're going to do now is we're going to take a slice of this dependency graph, and I'm going to demonstrate this to you, because I could just show this to you in just like a couple of minutes, how, what exports do, and how they help to solve this thing. But I really want to drive this point home, that this is still something that is relevant in the in programming in the large, right, for large applications. And so for this, I actually need to go and actually need to create this. And also, a lot of you guys, like, I've never created a very dedicated video for a clean architecture or any other layered kind of architecture, but I've always been like mentioning it in a lot of videos, and a lot of people actually have questions about this. So I'm going to keep showing this to you guys. So let me actually close this one, and even this one, and even this one actually. So let me actually run my terminal again, and I'm going to go into dev, and I'm actually going to remove the app. I'm going to remove the library, and I don't even need it to do app anymore. But I'm gonna leave it there for now. Okay. So let's go and create another project. I'm going to call it, well, let's call it app again. It doesn't really matter. Let's open it with Visual Studio Code. Now, VS Code has no idea that we actually removed the folder, so it thinks that these things are still in there. So as you can see, when I click it, it's just dying, and I don't want to import the build anyway just yet. So we're going to go to the build, and what I'm going to do over here is I'm going to convert this into a multi-build, right? So I'm going to pretend like this is a big application. I'm going to have a slice of a dependency graph. Okay, so over here I'm going to go and I'm going to say that this thing aggregates core, and today I'm going to call it storage. I'm not going to call it persistence. And then we're going to use some Google API, not a real one. We're just going to pretend like we're using, and main, where we're going to assemble everything together. So now over here, I'm going to grab these things and this. And in fact, I actually don't need this, and I don't even need the name. I can actually just do it like this. Okay, so this is going to be the core. Okay, and it's going to live in 0.1 core. We don't need this, and it's going to have the dependencies over here because we're actually going to write a couple of tests. And let's not forget to also have the common settings. Okay, so this is going to be the core, and I'm just going to paste it a couple of times, right? So we're going to do this, and we're going to do that, and we're going to do that. Okay, so this is the core. This is going to be storage, and it's going to be on 2. It's not going to have any dependencies. It's actually only going to have the dependency on core, and we're going to have this thing called cctt, which actually comes from import util over here. Util is just a thing that I created, and at the bottom it has a val called cctt, which is an SBT thing. It basically says that everything in the compile scope is going to depend on everything in the compile scope. Everything in the test scope is going to depend on everything in the test scope, right? So over here, if I have some stuff in the test in core, I can actually access them in my tests in storage. I have no idea why it's not done like this by default. Maybe it actually is done like this by default recently, but the last time I checked, which was like 7 years ago, it wasn't. Okay, so this is going to be storage, and it actually looks more close to what I need for Google. So I'm actually going to do this, right? It's going to be faster. Like this, and this is going to be the main. It's going to live on layer 3, and it's going to depend on both the storage and on Google. Okay, actually Google should be above. I kind of like things like if they're on the same level, I like them to be sorted alphabetically. So this thing and this thing and this thing and this thing, this should be called depends on. Okay, and usually I like to have settings below. Whoa, how did you get here? Below, and yeah, I guess this makes sense. Let's try. Import the build. Let me actually open the File Explorer, because when it's going to import the build, then it's going to generate all these folders for me. All right, so it looks like it works. So the first thing I'm going to do is I'm going to go over here. I'm going to create a new folder. I'm going to call it source like this. And I'm going to move the task from this big aggregate project in there. I'm going to leave the main over there. It's going to be fine. Let's actually go and start SBT just in case. And let's actually do main/run and just do this all the time. Like this. Okay, no main class detected. Why? Oh, because I didn't move this guy. There we go. Right, so now it's in main, sort, blah, 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 and now we see hello world, and then we're gonna do this. By the way, this is some weird VS Code thing. This should be, like if I go to settings, and I go into a terminal font, right? I'm gonna switch this to 19 and then, back to 20, then it's gonna look awesome. Like what's up with that? Software these days. All right, let me actually close this, close everything. Okay, so what I'm going to do over here is I'm going to go and I'm going to say, let's create a source main scala dev inside your app. Now, this use case that we're going to build is going to be called comparison. Okay, and inside of it, we're going to have a boundary.scala. There we go. Great. So as always, we're going to do this package app, and we're going to do this package comparison. Okay, so over here, I'm going to have a trait called boundary like this, and it's going to have just one gigantic method. It's going to be called does Google have more pictures than the last time we checked? And it's going to be the pictures of something, very likely to be the pictures of cats. Okay, just this one trait. Okay, over here, we're going to have the implementation. It's going to be a boundary. Okay, and it's going to have make. By the way, this is just a pattern. Like you could just have a class that implements it, but then you wouldn't be able to use the same name. This factory pattern kind of got very popular, especially with the tagless final stuff. Okay, so it's going to have a dependency on two other traits that are going to be called Google, and they're going to be called storage. They're going to be defined over here: trait Google, trait storage, empty for now. Boundary equals, and this is going to be the implementation of the boundary. So we can just say new, right? We don't have to say new boundary because this is scala 3. So we're going to have override. Again, the override keyboard is actually kind of optional, but I always prefer to have it. Okay, so we're going to have this thing. Okay, so what is it going to do? Well, it's going to grab hours first, hours. So it's going to go and say storage, count our pictures, count our pictures off. Okay, so we need to go to storage and we need to go add this method. Okay, so it's going to be def this thing, and it's going to have off, which is a string, and it's going to produce an integer like this. Okay, so this is the first thing that it's going to do. Then it's going to do the same thing for Google's, right? So whatever is in Google's. Okay, so we're going to have Google, and we're going to have count. Every time I spell count, I have an R over there. I don't know why. Okay, so count Google pictures off. Therefore, we're just going to duplicate this thing, bring it up like this, and colon, and let's grab this guy, let's grab this guy. Okay? Right. Again, this is scala 3 indentation-based syntax, so we don't need curly braces. This is all fine and dandy. Okay? So now what we're going to do is we're going to store it, right? So that next time it's still going to work. Update picture count off Google's, right? So this is the new thing that we grabbed. So we need to go over here and we need to have update, come on, picture count off, and off is a string, and new count, which is int, and it's just going to be a unit. Okay. Right. So now that we have these two things, we're just simply going to return Google's greater than ours, right? So this is the whole thing. This is the whole business logic, and this is called storage, right? So it's very clean, very, very simple. But sort of now we have like two things instead of one that we need. Now, usually I would put these two guys into their respective files, but this time I'm simply going to create a file called EntityGateway, and actually maybe I can. Well, no, I'm just going to do a new file, EntityGateway, and a bit later you're going to see why it's called like this and why both of them are in the same file. They don't need to be; they just kind of belong there. Okay, package comparison, and I'm just going to simply grab these two guys, put them in there, and store this file. There we go. So we have our boundary with just one very, very long method like this. There we go. And we have the EntityGateway, which has two of these traits. Now let's go and create two implementations. By the way, they're in two different projects because they're going to have totally different dependencies, right? So this thing is probably going to have some HTTP client like STTP or whatever HTTP4S. This one is probably going to be some database like Postgres. It's going to have some Postgres driver like Skunk or Doobie or whatever, right? So this is the reason why they're in two different things. Okay, so I'm going to go over here. I'm going to do source main scala dev inside you app comparison google.scala. And there we go. Like this. It's over there. Same thing as always. I wish that this was a configuration actually in Metals to tell it like, hey, feel free to generate this stuff, but please always generate it like this. And, somehow I would need to teach it that, what should be on the first line, and then everything else should just be split one by one. Something like this. All right. So what we're going to do is we're going to have object. And by the way, you cannot have an object Google in here, right? Because this is a companion object. I have no idea how this actually compiled. This is probably going to fail at runtime. I'm actually going to leave it like this because this is a companion object for this thing. And the companion object, it has to live in exactly the same compilation unit. Like probably if I clean, it's actually going to die. And this is like one of those, jar hell things. It should not compile. Maybe this limitation was lifted in Scala 3 somehow, but yeah, let's see. I'm actually going to leave it like this, and we're going to see. Like usually I would call this Google implementation like this. Okay, so now let's go and do make, and now over here I'm going to need to say Google, and it's actually still going to work because there's still no collision, which is fascinating. Let's see what's actually going to happen. We could use a sem type, right? There's only one method, but we're not going to. So I'm just simply going to do override, and I'm going to go over here and I'm going to grab this thing. Right, and like this. So I'm going to ignore the parameter, and I'm simply going to return 1,000. Right. So this is not a real application. Okay, not found type Google. Why? Google. Google. Probably like this is the thing that is like starting to cause us issues. So let's go right away and do it like this. Right. So now it compiles. Right, and Metals is not happy for some reason. Right. So yeah, like I warned you in the previous video that like this is like one of those things that you have to like really that you have to understand really well. In fact, everybody in the team has to understand this, right? Okay, so we have this thing. Now let's go and replicate this. Let's go for storage. What do you mean not found tab Google? Is dev inside you app comparison? Did I mass? No, SPT compiles, right? Oh, hold on. Maybe this is actually not good. Hold on. There we go. Right, so now it compiled more. Okay, so it actually works, which means that in the build, I actually did not make a mistake, right? There we go. Yes, Google depends on core, so it should totally see it. I have no idea what is wrong with Metals again. It should totally see it. Let me kill it real quick, just in case. I'm going to cut it out from the video. Okay, it's fine now. So let's go and do the same thing for storage. Okay, so we're going to have source main scala dev inside you app comparison storage dot scala. There we go. And let me actually grab these guys. It's going to be faster. All right, so we're going to have object storage implementation, and we're going to have def make storage equals new column. And then we're going to have override. Well, actually, let's just go and grab these guys. Grab, insert like this, and we're going to have override over here. And we're going to have override over here. Okay, so let's just say 50. We're totally ignoring the argument. It doesn't really matter. And let's just, saved. Okay, we're not even going to have the print line. Doesn't really matter. Now let's have a dependency graph, and there are always at least 2 dependency graphs in your applications, right? So the real one and the one that you're going to use in the tests, and it's going to be important in just a couple of seconds or probably minutes. Okay, so we're going to go over here, same thing, source main scala dev inside you app comparison dependency graph dot scala. All right, so same thing as over here, like this. We're just going to do object dependency graph. It's going to make, and it's going to construct a boundary, right? This is its purpose, right? So it's just going to do boundary.make, and we're going to have Google implementation.make, and we're going to have the storage implementation.make, like this, right? So this is not rocket science. Okay, it's a very, very simple constructor dependency injection. Okay, let's actually go into our app over here, and we're going to have print line. Okay, we're gonna do comparison, right? It's because over here we're not in the package comparison, right? We're gonna assemble like all of the dependencies over here, right? Comparison dot dependency graph and dot make and does this thing, and let's do cas, but it's actually gonna ignore it, right? All right, so let's go and run, and it's gonna be main / run like this. There we go. True. Google has more pictures of cats than we do. And I'm gonna fix the settings over here because I really like my hyphens. Okay, there we go. Nicer hyphens. All right, so now let's actually go and write some tests. Okay, so we have an example suite over there. Let's actually go and create a new file over here. We're gonna call it boundary suite.scala, like this. All right, so we're gonna have, oh, it's inside of app. Hold on, we need to do new folder, comparison, and the boundary should be in there, right? Again, like this is this location-oriented development. It has to be here because otherwise it's not gonna compile. Well, technically it still will compile because Scala doesn't force you to have a match between your file names and your packages, right? So you can still have it like in completely different places, okay? So we're going to have a final class boundary suite extends test suite, okay? And over here we're going to import the boundary suite, which is going to be the companion object. This is sort of like always like the default thing that I do, okay? And over here we're going to have a test. We're going to call it test1. I'm simply going to say 1, and by the way, 1 should be 1. In Scala 3, you cannot use methods in the infix notation unless they're either symbolic or they are marked by library authors as allowed to be used as symbolic operators. As of right now, Scala 3 is not completely out. I'm recording this on May 9th. This is Scala RC3. Scala 3 is actually going to come out in just a couple of weeks. So even though Scala test is already published for Scala 3, it is still not done in this Scala 3.1 compatible fashion. So so the compiler is going to bark at me that I cannot use it in the infix notation, but it's also going to rewrite it for me. Check this out. Have you seen it? It just added these quotes. Right, but this was too fast for Metals, so Metals didn't really see it. Let's actually do this and do this, and now Metals is happy. Now it refreshed the things. Okay, so let's actually go and run all the tests. Let's actually remove the example suite. We don't need it. Now, it's really, really important that we actually write the test because my main issue, and it is the one that exports are going to solve, is the fact that tests are a little bit harder to write. Because if I had, like, right now, the boundary needs 2 things. If it had 10 things, I would need to fake 10 things. Okay, so what I usually do, and I don't like to use mocking libraries, I actually go over here and I create classes, not final classes. I call them like fake, right? So, for example, fake Google extends Google. Okay, and as of right now, Metals cannot generate the implementations for Scala 3, so I have to grab this thing, okay, like this. And in all of the implementations, I throw the exception, right? And like literally all of them. Okay, let me grab this, paste it over here like this. Okay, so this is going to be fake storage, and count our pictures, and another one in storage is this one. Right, so I could return a unit, right? But the purpose is that I throw the exceptions, and then in my tests, whenever I use these fakes, I only override the things that I actually need, right? So the things that I know are going to be called, okay? And so I want to show you like this, like sort of like pain and boilerplate that you're going to have when you're going to write these tests. So usually I go like this, right? So I say, okay, so let's have a Google, okay, which is going to be new fake Google, right? And then if I needed something, I would go over here and I would start like overriding things, right? The things that I defined over here, not all of them, like only the ones that I need to. Like this is actually a bad example because over here, you know, the only thing that we have is this gigantic method, and it actually uses all of the methods, like all of the 3 methods that we defined. It's actually not a perfect example. Okay, so let's have it like this for now. Let's have a storage over here. It's going to be storage, and we're going to have new fake storage, right? Like none of this stuff is rocket science, okay? This is very simple constructed dependency injection, right? Make Google and storage like this, okay? So what are we going to test here? Well, because I didn't override anything, then this thing should just fail. So I'm just going to say a not implemented error should be thrown by boundary dot does thing gets. Okay, so it's going to be green. You know, never trust a test that you haven't seen fail. So runtime exception. There we go, and it fails. Great. There we go. Okay, let's write another one. Right, and in another one, I would have to fake them again. Right, like this one is going to be called test2, and this time I'm actually going to go and I'm actually going to override a couple of things. Right, so I'm going to say override, and I'm just going to grab it, this one. So let's say 10. Okay, now for the fake storage, I'm also going to override them. I'm actually going to override both, right? Because like again, like our boundary uses both of them, so I actually need to override both of them, right? Like this and like that. And so let's say that we had 20, and well, this is how it's going to store stuff, like this. Okay, so now what we're testing is that this thing, okay, so that this thing should be false. Okay, let's also set it to true and see that it actually fails. True, it fails, false, it's right. Great. Well, that took forever. Now imagine that I had 10 dependencies, and imagine that I had like 20 tests, and all of them I would have to do something like this. I would have to fake all of them. I would have to inject all of them. There are some things that you could do to mitigate this, right? You can have a private def that would do these things for you, or you can use a mocking library that I don't really like. But yeah, essentially I want to have a way to only have like one thing that I need to fake. And it's also very, very convenient to program against something like this. Like imagine that like this boundary, right? It had like 10 dependencies, right? And over here I would use like, sometimes I'm going to use this one, sometimes I'm going to use that one, right? And I always have to know which one I want to use. What I would like to have is I would like to have like one big object that just has everything that this boundary needs. And it's not a big problem because this object is going to be defined in exactly the same namespace, right? So everything that I'm creating over here is specifically for this thing. So it's not a big deal. Now, what most people do is they simply, you know, if you have like 10 things, they just throw them all into one case class. They call it, I don't know, config or something, right? And then it, you know, makes it like slightly easier to pass around. But usually you don't have like many layers of how you need to pass it around. Well, sometimes you do. I don't know about your use case, right? But this is not my main issue. My main issue is that I want to fake only one thing. And the way you do this is by using facades, right? And before we're going to use them, we're going to go and make a Git repository out of this. Okay, so close this. There we go. Okay, so all I'm going to do is I'm going to go over here. I'm simply going to have a trait. I'm going to go with EntityGateway, big surprise. And I'm going to say extends Google, comma storage, right? This is a Scala 3 thing. You don't have to say with. Okay, so now I have only one thing, right? So I can go to the boundary and I can go and I can say gateway, like this, right? And I can simply call like everything like gateway here. By the way, if for some reason you actually need, it doesn't compile somewhere else, okay? So if for some reason you actually need to get back like your original types, you can still get them out, right? You can still say, you know, Google equals gateway, and the same thing for storage, right? Storage gateway like this, and you can go back and use them if you really want to, right? Google and storage, right? No big deal. Everything compiles in this file. Okay, let me actually revert this stuff, right? But usually there is no need, right? But I'm just saying, like, you could write, like, if you have like a private def and you want to kind of constrain it a little bit more, you can say, okay, like this is a private def that is only going to work like with the Google thing. You still can, like the types are still there. Now it actually saves me a lot of code in my boundary suite, right? Because over here, right, I could still do this, or I could just say that this is not a fake Google, this is a fake entity gateway, and it extends entity gateway, right? And now I would not need this, right? It's exactly the same thing, okay? So now over here, I can go and I can say that this is a gateway, and this is a entity gateway. This is a fake entity gateway. I don't need to do this. This code, becomes smaller, right? Gateway like this, okay? So I can do the same thing over there, right? So over here, right? So this is now gateway. I can just remove this stuff, right? Same thing. And now I'm gonna go over here, gateway, like this. I still did something wrong, not found type, which means that this is a typo. Fake entity gateway extends entity gateway. This is correct. Fake entity gateway. Okay, hold on. Double click. Yeah, it's there. It should be fine. Oh yeah, if I got a colon over here, right? There we go. Yeah, right. So see, like this is less code. Like I don't need to fake 10 things. I can just fake one thing, right? Okay, but like the meaning and everything is still exactly the same. In fact, as of right now, it already says like, hey, all tests pass. So DI is much simpler now. It's much easier to write tests now. It's easier to pass things around. It's easier to inject them, except for one last thing, the actual dependency graph. Before we actually go there, let's actually have another commit, even though it doesn't compile, right? So we're gonna do gcam before composition over inheritance. Okay, so let's close this guy. Okay, so we still have a couple of things that don't compile, namely the dependency graph, right? Over here. Now, this thing doesn't work anymore because it wants the entity gateway and it doesn't want like these two things. And the question is, how do you combine them? And there are two ways, inheritance and composition. And inheritance has support in most programming languages, in Scala as well. Composition doesn't until now, until Scala 3. So let's do inheritance first. So we're going to go to storage, and this whole thing is going to be a trait now, right? Storage implementation, and it's just going to extend storage, extends storage, right? Therefore, we're just going to have a column over here, no new over here, do it like this, all right? Same thing for Google, right? It's going to have over here, it's going to have extends Google, and this is going to be a column, no new, like this, all right? Now we can go over here, and now we can say it's going to be new entity gateway with GoogleImpl and with StorageImpl, like this, okay? Not found, what? GoogleImpl. What do you mean not found? Oh, it's still an object, right? It needs to be a trait. There we go. Okay, so now everything works, and now we can actually run the main method. This compiles, okay? So now we can go and we can do main/run. There we go. True. Okay. So Google has more pictures of cats than we do. Okay. So let's actually look at the diff. Let's go over here. Right. So this is the diff that it produced. Okay. So this thing was written to a trait. This thing was written to a trait. So if you have like 10 of them, you have to rewrite all of them to traits. Okay. Now this is way too powerful for what we need, but it is so convenient that I'm sure that many of you would prefer this solution until now. So let's actually revert this. I have an alias grhh, which is git reset hard, grhh. Okay. So now this stuff doesn't compile anymore. So now I'm going to use composition. Right. So over here, we're simply going to have a def called entity gateway. Right, we're just simply going to grab the things that the boundary used to take, right? Google and storage, and it's going to produce an entity gateway. How's it going to do it? Well, it's just simply going to say new, right? And then it's going to grab this guy. It's going to grab, well, it shouldn't move it. It should duplicate and move. Right? So it's going to go and it's going to do like override, okay? It's going to be equals, and over here it's going to have, well, basically whatever it has over here, like this, off, and over here it's going to have new count, and over here, this one we're going to call it on Google, and this one is going to be called on storage. This one is going to be called on storage. And yeah, I believe that's already it, right? Isn't it? Yeah, like this is already it. So now all we need to do over here is we need to surround this with parens, and we need to go and to do entity gateway over here. Entity gateway, like this, right? And everything works, right? So let's look at this diff now, right? And we're not even using exports yet, right? There we go. This is like way cleaner, isn't it? We just added code and only fixed the dependency injection part, right? First of all, this is cleaner. And second of all, exports can do all of this stuff for us, like all of this stuff, right? We're just delegating to these things. So all we need to do now is we need to export google.star, comma, storage.star. And I didn't save the file yet. I actually want to kill this guy, okay? So as you see that I'm going to save the file and it works exactly the same. This is freaking awesome. Let's look at the diff now. Damn. Notice that neither of these things, like neither inheritance or composition, actually affected the way we created a dependency graph in our tests, right? Over there, this problem was already solved. All right, so this is pretty much everything that I wanted to show you today. I'm actually going to show you one teeny tiny thing that is sort of related to it. There's this thing that worked even in Scala too, and it looks very, very similar to export, but it's very, very limited, and you kind of have to like spell things out yourself. So imagine that if you had a trait called abstraction, and again, this is going to work in Scala 2 as well. Okay, we can actually switch to just compilation. There we go. This is all we need. Okay, so it's going to have a name string, and then we're going to have an age int. Okay, so now we have object abstraction, right? And it's going to have make, and imagine that it had like these things in there, right? Right, abstraction, okay, equals new colon, and we would say, you know, override val name equals, which is a string, equals name. And I'm not even sure if this is going to compile because we're using exactly the same name. And equals age. Okay, well, at least it's going to compile, but probably it's going to fail at runtime. Okay, but that's not the point. The point is that if you go like this route of just, hey, let's just have a case class for this thing. Okay, so let's just go and have a final case class, person, name, string, age, int. Okay, they don't even have to be called the same. Okay, so if you use a person over here, I'm just bringing this up because a lot of people don't know this, and it actually is very, very similar to exports. Check this out. What you can do is override val, and then you can deconstruct the person, right? Right? So we're override, like these things, they're being thrown into the scope, like the same as like exports would do. Like, so it's kind of like the same thing as we're doing over here, but this thing is like obviously way, way more powerful. Okay. By the way, I was playing around with this thing. And I accidentally, right? But by the way, like this is, again, like this is exactly the same thing as just saying export person star, right? This is like way more powerful, right? So because we don't need to name things. I was playing with this thing, and I was like, hey, so why at this point, like, why do we even need this? Like, can't I just do this? And can I just like do like export name and age? And this doesn't seem to compile. So I was like, maybe I can do this. You know, maybe that's gonna work. Well, this .age, and this worked. And I was like, what if I can, like, maybe I can just put a star in here, and I can say like, just export everything that I have over here. Oh, and I mean like this star, and then this thing compiled, but it actually produced a Stack Overflow at runtime. I'm actually going to show this to you because like this thing is effectively the same thing as we have over here, right? So if you just go and if you export this star, then it's going to compile, right? But it's going to fail at runtime. I actually have no idea whether it's a bug or if it's just a limitation, right? It's just a Stack Overflow. It probably shouldn't compile, but then again, things like, you know, val x equals x also shouldn't compile. And by the way, just yesterday, like when I was actually playing around with this and I noticed this, I posted this tweet. I'm actually going to show this to you. I'm actually super curious what came out of it. Check this out, Twitter dev inside you. Right, so I posted this tweet. Like, what does this Scala code do? Right, val x int equals x, println x, and guess what? The correct answer is, and I was surprised as hell, is actually this. It actually prints 0, and only 10% actually know this, and 12% are not sure. Let me actually demonstrate this to you. Check this out. We're gonna go to main, and over here we're going to do val x int equals x. Right, compiles. Println x 0. Check it out. String. Null. Check it out. Char. Empty char. What else do we have? Boolean. I haven't tried with Boolean. False. What is happening over here? And then I went to Scala 2, and the same thing is happening. This is crazy. They did change though what is going to happen if it's a def. Okay, so if it's a def, over here it's going to fail at compile time. It's going to say infinite recursive call. Actually, haven't tried if it's going to be so smart. If I do something like print line, whatever, is it still going to be smart? No, it's not going to be smart. See. So this is basically just a warning that was turned into a compilation error. Okay, so this is this never finishes, and in Scala 2 it's the same thing. It never finishes. Right, so basically the point is that probably like with the exports, exactly the same thing happened, right? So if we're actually going to do this, let's see, right? If we're actually going to do this, then it's never going to finish, right? So it's running now and it's never going to finish. And in Scala 2, this was actually a stack overflow. Okay, just so that you know, because it's it's kind of similar to what we have been discussing with the exports, and yeah. Go away like this. In any case, as already mentioned, top-level definitions and exports are my favorite Scala 3 feature. What is yours? Let me know in the comments below. And again, as a reminder, jar hell is real. You can really shoot yourself in the foot with all of this stuff. But come on, it's really awesome. Come to the dark side. We have cookies. In any case, I hope that you enjoyed this video. I'm going to see you in the next one. But for now, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did. Subscribe if you want to improve the developer inside you. And if you learned something today, consider supporting me on GitHub sponsors or Patreon, whatever you prefer. And let's watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.